Hello everyone, my name is Ritesh Verma and today I will be presenting my work on optimizing Liquid Galaxy UX mode using Openbox. When the people see Liquid Galaxy for the first time, what they usually notice is visual experience where multiple screens, synchronized views and immersive navigation. But what often goes unnoticed is the system design that make this experience stable, reliable and suitable for the public environment. In this presentation, we will take you first step by step through how Liquid Galaxy work as a system, how Linux display content, why Liquid Galaxy Manager is so important, why kiosk mode is required, and how OpenBox enforce that kiosk behavior. And finally, how we make the system recover automatic after the crash. We will move slowly from the concept to practical behavior. So, if you are new to some of these ideas, everything should be clear by the end. Let's begin with how Liquid Galaxy work as a system. Liquid Galaxy uses a master-slave architecture. There is one master node and multiple slave nodes. Each of these nodes is a separate machine and connected over a local network. The master node is responsible for control. It handles things like user input, navigation commands, and dealing what should be shown. The slave node are responsible for rendering. Each slave display a specific portion of the visual content. Now the key idea here is synchronization. When the master node sends a command, for example, moving the camera on the Google Earth, every slave must update at the same time. If one of the screen lags, crash, or behaves differently, the entire experience breaks. That's why Liquid Galaxy system depends heavily on practical behavior, synchronization, and minimal interference from the operating system. Another important point is design philosophy. Liquid Galaxy avoid a heavy desktop environment because it's not meant to be a personal computer with menus, launcher, or notification bars. It's meant to be public installation used in museum, exhibitions, or research labs where where each machine is running for long hours without supervision. So from the very beginning, Liquid Galaxy is designed around the stability, control, and simplicity. Now, Now that we understand the system architecture, let's talk about how Liquid Galaxy display content on Linux. Linux use a layered display system. This separation is actually what gives us control. At the base, we have a X11 display server. X11 is responsible for managing a screen, handling input devices like keyboard and mouse, and allowing application to draw content. Application does not talk directly to the screen. They talk to X11 and X11 handle the display. On the top of the X11, we have three important roles: display server, window manager, and desktop environment. The display server handles the display and the input, whereas the desktop environment adds things like panel, menus, notification, and UI tools. But the window manager is the component that decides where the window appears, which window is focused, and whether something runs full screen or not. Linux intentionally separated these responsibilities. This separation is exactly what allow us customize behavior of the Liquid Galaxy. Liquid Galaxy does not need a desktop environment. What it need is strict window control. This brings us to an important question. Why does window manager matter so much in Liquid Galaxy? Liquid Galaxy is not about multitasking or window switching. It's about presenting one continuous experience across multiple screens. The window manager is responsible for enforcing full screen behavior. It controls window focus, especially important in multi-screen displays. It also decide how the user input is handled. There are different type of window managers: stacking, tiling, and dynamic. Stacking window manager allow overlapping windows, where tiling window manager manage automatic arranged windows. Uh, On the other hand, Dynamic Window Manager combined both approaches. That's why stacking window manager are the best. Now that we understand how Linux display content and why window manager is important, the next logical question is which window manager should Liquid Galaxy use? Liquid Galaxy is not a typical desktop system. It does not need menus, panels, launcher, or animation. What it really needs is control. This is where Openbox is come. Openbox is a lightweight stacking window manager. Stacking means window can overlap, but more importantly, it gives us explicit control over the window behavior. Openbox focus only on window management, where windows appear, how they behave, and how users can interact with them. It does not include taskbar, docks, desktop icons, or background services. And for Liquid Galaxy, that's actually perfect. In multi-screen setup, every extra UI element is potential problem. A panel showing up on the screen or a menu popping up accidentally can break the experience. Openbox gives us full control over the full screen behavior. We can focus application to start in full screen, prevent them from leaving it. It also gives us predictable focus handling. The active application always stay in focus even across the multiple displays. And because OpenBox is extremely lightweight, it uses very little CPU and memory. This means more system resources are available for rendering and synchronization. The execution flow is very clean and easy to reason about. The execution flow. The system boots, then X11 display server starts, and then OpenBox launch as window manager. Now finally, Liquid Galaxy application start directly in the full screen. There's are no extra layer or no necessary component, such that this simplicity is not a limitation. It's a deliberate design choice that makes Liquid Galaxy more stable. Now that we have the right window manager, then the next question becomes why does we need kiosk mode at all in Liquid Galaxy? First, understand what is kiosk mode. Kiosk mode means that the system is restricted to a single purpose. Applications run in full screen and the system UI elements are hidden, where the keyboard shortcuts and the escape paths are also disabled. This is essential because Liquid Galaxy is typically used in public environment like museum, exhibition, or research lab, where uh, environments are not controlled. People walk up to the system and interact with it freely. Those users are not technical, they don't know which key are safe to press, and they shouldn't have to. But people press keys randomly, or they right click, or they try to explore. These actions are not miscellaneous. They are completely natural. But in multi-screen system, one accidental action can have a huge impact. If someone minimizes one window, the entire display wall becomes inconsistent. If someone exits an application, the impressive experience is broken. Liquid Galaxy system also run for long hours without any supervision. There is no operator standing by to fix these things. So, kiosk mode is not about restricting users. It's about protecting the experience this and the system. It ensures that Liquid Galaxy behaves the same way every time, no matter who is using it. Now, let's go to the next slide. So, let's look at what actually goes wrong if we don't use kiosk mode. The most common problem is accidental exit. Application can be closed or minimized unintentionally. In single screen system, this is annoying. But in a multi-screen Liquid Galaxy setup, it's a disaster. Even one closed window breaks synchronization. Another issue is desktop exposure. If the application exists, the Linux desktop becomes visible. Now the public can see a system UI and file manager or the system settings. This is not only unprofessional, it's also a security concern. Then there's a window misplacement. Application might open on the wrong screen. Window may overlap or become misaligned across the displays. The carefully designed visual continuity is lost. And finally, there is a loss of immersion. Liquid Galaxy is all about immersion. Once the illusion breaks, the experience feels confusing. People lose interest immediately. That's why Kiosk mode is not a nice to have a feature. For Liquid Galaxy, Kiosk mode is a requirement, not an option. Up to this point, we have talked about why Kiosk mode is required and what goes wrong without it. Now let's finally answer the most important question: how OpenBox enforce Kiosk behavior to Liquid Galaxy. This is where the OpenBox stop being just a window manager and start acting like a control system. Let's start with full screen enforcement. In a normal desktop system, full screen is usually just a request made by an application. The application says, I would like to full screen, and the window manager may or may not allow it. But in Liquid Galaxy, it is not good enough. Here, full screen must be mandatory, not optional. OpenBox allow us to enforce full screen at a window manager level. That means applications are forced to start in full screen, and more importantly, they are forced to start here. Even if application crashes internally or tries to resize itself, OpenBox can override that behavior. This is critical because in multi-screen environment, even a small resize or border can break the visual alignment. Now let's talk about window focus. Focus sounds simple, but in multi-display setup, it's actually one of the biggest source of bug. In normal desktop, switching focus between windows is expected, but in Liquid Galaxy, focus must remain locked to an active application. It focus if focus jump to another window or another display, the keyboard and mouse input may go to the wrong place. Imagine someone interacting with one screen, but the input suddenly affect the another screen. That completely break the experience. OpenBox allow us to look focus to the intent application and prevent focus switching. This ensures that all the user interactions stay exactly where we want it. Now, let's come to the most visible part of the kiosk enforcement, escape prevention. In desktop environment, user rely heavily on shortcuts like Alt plus Tab or Alt F4. But in public installation, these shortcuts are dangerous. One accidental Alt plus F4 and the main application is gone. OpenBox allow us to intercept and disable these shortcuts completely. We can also remove the right click menus or window decoration and title bars. At this point, the system no longer behaves like a desktop. It behaves like the user can't explore, they can't minimize, or they can't escape. They can only interact in the way the system is intent. This is the moment where the open box becomes the controller layer of the Liquid Galaxy. The system stops being flexible and start being reliable. Now that we understand how kiosk behavior is enforced at the runtime, let's talk about something just as important is startup behavior or startup workflow. A kiosk system is only reliable if it starts correctly every single time. Think about a real world condition where a power failure happens, system reboot, or a machine and then machine get restarted. When Liquid Galaxy start, it must always come back in a stable state. So, what actually happened during the startup? First, the system boots and initializes the hardware. Then, X11 display server starts. At this point, nothing is visible to the user at. Next, OpenBox launches as a window manager. This step is extremely important. From this moment onward, OpenBox is in control of the display. Only after the OpenBox is running to Liquid Galaxy application starts. These applications are launched automatically using a auto start mechanism. They open directly in the full screen mode, so that there is no moment where the desktop become visible. There is no opportunity for the user to interrupt the flow. This startup order is not accidental, it is carefully designed. If applications start before the window manager, we get a risk condition. If the desktop start first, the user may brief see the system UI. By controlling the startup order, Openbox ensure that kiosk behavior is enforced from very first frame. This means that even after a crash or reboot, Liquid Galaxy always return to a same predictable state. So far, everything sounds perfect, but real systems are never perfect. Crashes happen, application freeze, process die, or memory leakage occurs. In long-running public installation, crashes are not an exception; they are expected. The real question is not whether something will crash. The real question is what happened after the crash. Let's simulate a real-world failure. First, we start all these virtual machines. Now, let us see. First, we will stop crash manually uh, one of the slave, and then we will see that the slave start automatically. Let's see. Let's go to the slave 3. Uh, to kill this, we use this command. We will see that the Google Alert automatically start after the crash. As we can see that the system is automatically start now. Now let's try with LG2. As we can see that Google Earth is closed and then automatically restart. This is how Openbox work. Kiosk mode works. It automatically start the each slave after the crash. As we have see that a monitor script detect the stopped application and the Liquid Galaxy slave restart automatically. The application relaunch in full screen and the desktop never become visible. From the user's perspective, the system simply recovers. So, at this point, we have gone through the entire journey from understanding how Liquid Galaxy works all the way to how it behaves in the real world condition. This final slide is not about introducing anything new. It's about connecting all the dots. When we start, Liquid Galaxy looked like a collection of a screen running an application. But we understand that it's actually a tightly controlled system where every small behavior matters. By introducing open box in the right way, the first thing we achieved was control. Liquid Galaxy now runs in locked full screen kiosk mode. There is no desktop in the background, no panels, and no visual distractions. From this moment, the system starts, it behaves like a single purpose installation, not a general desktop computer. That immediately remove an entire class of problem where user can no longer accidentally minimize a window or exit an application. There are no escape route into the operating system, and that leads to the second major achievement and predictability. Application always open in the correct position, and window focus stay consistent across all the screen. In multi-display environment Liquid Galaxy, this is a critical. When focus and positioning are predictable, synchronization stay intact, and the immersive experience remains smooth. Another important outcome is the reliability in the public environment. Liquid Galaxy systems are often left running for long hours, sometimes days or weeks, without anyone supervising them. By removing accidental exit and window misalignment, we reduce the chance of the system drifting into a broken state. And even when something does goes wrong, which is inevitable in long-running system, the system is designed to recover on its own. Application automatically restart after the crashes. They come back in full screen. Kiosk behavior remain active, and at no point does the system require a human to set up in and fix things. This is what make the setup suitable for unattended public installation. It is also what make it safe for non-technical users. Users do not need to know what's running under the earth. They don't need the instructions. They just interact with the experience, and the system quietly take care of everything else. And when we step back and look at the bigger picture, this is most important achievement. Openbox allow Liquid Galaxy to behave not like a desktop computer, but like a purpose-built system. A system that is stable, predictable, and resilient. A system that prioritizes experience over flexibility. And that ultimately is what Liquid Galaxy is meant to be. This is why choosing the right window manager and using it in the right way makes such a big difference. Thank you for taking the time to watch this presentation. I hope it clearly explains how OpenBox help Liquid Galaxy remain stable, controlled, and reliable in real-world public installation.